Okay, all right. Thank you everyone for coming. And I am very excited to be here. This is Jaya. I work in Morgan Stanley Release and Change Management team. I have here with me Rita, who is the head of Release and Change Management team in Wealth Management Technology. I have Mainak here with me. He's the principal architect in Platform Architecture Services. I have Sehgal here with me, who is the chief architect in WM Architecture Services and Emerging Tech. So we are going to talk about a topic that is on everyone's mind, artificial intelligence, and generative AI in particular. So we are going to discuss the challenge that we are trying to solve. Let me go over just a little bit of discussion points from here. We are going to talk about the change implementation request and the related challenge that we are trying to solve manually, and we are also looking to do a proof of concept that GenAI can help us with or justify the hype, so as they say. Then we'll talk about our take on risks and governance around AI. And lastly, we'll talk about a little bit about the proof of concept, the future state, and path to production. So, all right, let's get to it. Anybody here understands what is change implementation request? Okay, good. So those who do not know, it's basically a fancy word for a change ticket. So a change ticket is when you're going through a software development life cycle, you have changes to deploy in production. You cannot go into production without submitting a change ticket. And a change ticket would require you to fill a form and add a lot of information related to execution procedure, rollback procedure, etc., and you cannot go into production without that. Now here you see that we have two teams. One is software delivery team, and the other one is change managers. So software delivery team is the one that writes the code, and they cannot go in production without submitting the change ticket. At the same time, we have a change management team who cannot let anything go into production without reviewing a change ticket. So there are two teams who have the best intention to make the company successful. They're just finding a little bit hard time to do their jobs better because of either they're short on time or they have a large book of work to handle. So the problem begins when the number of change tickets increases from 10 to 1,000. So one team is continuously cutting tickets and the other team is continuously reviewing them. And when this team, the change management team, sends the tickets back to the software delivery team for reviewing, if they find some missing information or there is some data missing or they're not satisfied as per their quality standards because of the poor quality of data, that's when the problem mounts. But now we are getting somewhere because we are talking about data. Because where there is data, there is a problem. And then there is a potential solution as well. Sorry about that. Now that we are talking about the problem, so is this problem complex enough? Yes, no? Okay, I got thumbs up, so I take it that the problem is complex. So there is a solution, yes. That's what we are here to talk about, our proof of concept. So as Mr. H.L. Mencken said, that for every complex problem, there is a solution that is simple, neat, and wrong. So those who do not know Mr. Mencken, he was an American journalist, and he is very well known for his wit and wisdom. So what my message here is that yes, my problem is complex, and I might have found a solution for it as well, but it could very well be the wrong solution. And I'm hoping that GenAI might give us the right solution. But I think we are getting ahead of ourselves. So why don't we talk about how we are handling the problem today? So I have a team of quality reviewers who are doing this on a weekly basis. And as we just mentioned that there is a software delivery team who has to submit a lot of information. they have to fill in the information related to how the change will be executed, the implementation details. They have to mention how the change will be validated at the end of the production implementation. They also have to mention whether, if something were to happen, how the rollback could happen. There are a lot of different details that are needed for any change ticket, and there is a lot of data. And data, and just data. So that's when the problem arises that my quality reviewers team, when they're trying to review the information, it's not a sustainable solution for them. So what they did, they came up with the process of random sampling. Now, what they will do, they will pick up the random sample of change tickets, and they will validate against their quality standards. Now, the information in each change ticket needs to be understandable. It needs to have a proper description. And then based on the sample size, we came up with a couple of KPIs. These KPIs indicate that how we are doing from a software delivery team standpoint and from a change management's quality review standpoint. So the first KPI explains that how many changes were reduced, what was the sample size. The second KPI tells us about how many changes really passed our quality standard. And then based on the sample size, we extrapolate the results of the number of changes or percentage of changes passed based on the change volume, which could be thousands each week. Now, the third KPI that we came up with is how many poor quality fields are there in each change ticket. But if you're thinking that our process is complete, it's not yet. Because when there is a KPI, there has to be a threshold to measure. This is not a trivial problem to solve. We had to analyze a lot of data to come up with this threshold. And several weeks of analysis went into it with the random sampling. Now this threshold might not be telling the real picture of our quality review, but it is close enough to tell that on a weekly basis how our quality check is proceeding. Based on this check, we draft our responses telling the software delivery team that how your tickets are being submitted, whether they fall into strong, satisfactory, fair, or weak category. And then based on this threshold and the respective category, we also draft our responses to tell them where is the scope of improvement. So everyone with me yet? All right, so next we want to talk about, Next, we want to talk about, now that you know the problem, how do we break down this problem and break down the complexity using GenAI? So our problem is twofold. One is the quantitative aspect of it, when we say that there are thousands of tickets that we have to review. And the second part of it is the qualitative part of it, because there is data, there is a lot of information in each ticket, and we have to do the content validation for it. Now, we have solved the quantitative part of it at Morgan Stanley, and what we are doing with our proof of concept to solve the qualitative part of it. Now, as for the POC, what we are looking with GenAI to solve is, can it really assist the change managers to save their time? But how far can we really go? So I want to throw in some stats real quick here. There was a survey conducted by Dale Carnegie and Associates in 2021 for a group of 3,500 people, of CEOs, individual contributors across the globe, and 84% of the respondents came with this, that AI can bring in a positive value. But the role of human leaders in AI oversight still remains critical. So while our expectations with GenAI are that it will remove administrative and repetitive tasks from our plate so we can focus on innovation, and it also opens up our capacity to be more strategic, we still want to continue with this thought to keep computers in the group, but keep humans in the loop. What else it can do for us? While generative AI will work on performing the contextual quality check for us with near accurate and consistent responses, we can build a team of prompt engineers. With this additional skill set, we can tune in the GenAI models to get the desired output. And with that solution in mind, I'm going to hand it over to Mainak to talk about our proof of concept with GenAI. Mainak?
Using this. Hey, hi everyone. Okay, I'm the tech guy, and I'm a pretty much background of traditional ML, so I don't believe that GenAI can solve everything. So if you hear more about machine learning and all those stuff, but yeah, I'll go through my points because I have taken them and I want to go through all of them. Okay, so when Jaya and Rita gave us this problem, we find that, okay, this is like we have to validate 6 fields, whether they're properly filled up or not. And just we can do it through a normal generative AI few-shot approach. Like give them some better example and write a prompt, send it to LLM. LLM can just give you, okay, these are the fields, it is not properly filled out. You put more text on this, the way. But the main problem is in Morgan Stanley, we have too many divisions, too many groups, too many development teams, too many change requests. Okay, you cannot fit a single type of generic prompt, generic rubric for all the groups. So you have to first, when the change request comes, you have to figure out what kind of change request it is. And you have to put a pre-engineered prompt according to that. So you have to do a classification first. So that's why we took a 2-step approach. Okay, the first one is the easy thing that we can do. But what we did is the picture here in the bottom. So we take the change request, and then we use a small LLM, open source small LLM. I can tell you the name, Phi3. So first, we, as a traditional ML person, we first do a cluster analysis, like how many kind of change requests we have, what are the main clusters we are seeing using embeddings, okay? And then we fine-tune a small LLM to classify with this data to figure out that what kind of change request it is. So that once we know what kind of change request it is, we can put it in a bucket where we already have a pre-selected or pre-engineered prompt, okay, with its rubric. So that's the main goal. So think about you are classifying, selecting the prompt, and then sending the prompt and the data to LLM for completion. So now when we are looking at the LLM for completion, there also we actually, while doing the POC on some open source, like Llama 3 and all. But the main problem is if you are going into text generation into an open source model, the main problem is you have to do a lot of fine tuning. They will not give you as many good results the way you can see from anything from something like GPT-4 or so. So if you're looking for a quick win, again, GPT-4 is a much better option than Llama 3 and all. Yeah, Llama 3 and all will definitely give you better result if you want to spend more time on that, fine-tune with your data and everything. Okay? So, and then once you go to the LLM, you get the validation result. So the idea is at one point of time, we will have this kind of a report where the top part is a change request entry, which Jaya can see. And then in the bottom part, we have our like a validation result, like all this description, which are passed, which are not failed. You see a lot of spelling mistake over there. Just ignore them. Okay, yeah. So you can see it's human generated, not machine generated. So yeah, and the idea is as LLM can give you some of the gaps as well. It can identify the gaps. Like, okay, in the change description, you missed this part, okay? And a dial is always like a visual thing which will give you a easy understanding that where you are. I just want to go through the tech stack. So for the framework for writing code, we used LangChain. I mean, we explored LangChain and semantic kernel, which both are, I think, very popular. And definitely, I think when you are writing code, if you are using any of these frameworks, your code will be much structured. And then for LLMs, we explored 5.3. MPNet. MPNet we used for clustering. I don't know how many of you have heard of MPNet. There's a very small model for embeddings. Okay, it actually gives you a 500 array of floats. But if you fine-tune it, it works very good for clustering and classification kind of a use case. And then we use mainly 5.3 for the, all exploration, right? And Llama 3 for the text generation we used. Now, this is pretty much it. Still in the POC phase. We are seeing at the result. We are exploring the stuff. But while doing that, okay, governance and guardrails. Yeah, this is important because we're in the city of Spider-Man, right? Great power, great responsibility. Okay, I hand it over to Rita.
For the responsibility.
Yeah. Thank you, Mainak. So as Jaya said, when you get into the data realm and any computation where machine is trying to do something that humans were doing before, you have to have proper guardrails and rules and controls in place to make sure that you're not going worse. If anything, you get better. And also, as Mainak said, with great power comes great responsibility. So while we are still in the sandbox environment and we are still POCing these solutions, we already have our eyes on what are the risks that we may be looking at and how we can address those risks and get ahead of ourselves a little bit in the solutioning phase to stay on top of those risks and the mitigation plans. So the risks that we're looking at are the accuracy of the data, because garbage in is garbage out. So we have to make sure that the data that we are feeding and the prompts that we are feeding into the system are accurate and of good quality. So we are basically working on curating our data warehouse with all of the data sources and making sure that the data is of good quality. The second thing is consistency. So again, consistency of the data, but also keeping an eye on the results that we are getting to make sure that those results are somewhat consistent. And for the same change record, we're not getting different output different times, right? Trustworthy responses. So all of us have iterated that it's important that we can trust these systems. And I'll talk a little bit about how human is going to stay in the loop. Jaya mentioned it as well. But at the same time, if we have to look at each and every response from the model and figure out whether it's the right response or not, then the purpose is defeated right there. So we have to be able to trust the responses. And then audit liability. We all know, many of us in this room are from the financial industry. We are subject to a lot of scrutiny, and everything in the change management process is subject to audits. So we want to make sure that if we are deploying a process to assist us with the change management process, that it is trustworthy and it's not going to open us for any audit liability. So here are some of the guardrails that we have thought about. And again, this is in the infancy stage, so there might be more. But the initial thoughts are that, firstly, the human is going to stay in the loop. So it's not that if the AI model says the data is of good quality in this change ticket, that somebody is blindly going to approve that change ticket. We will still be reviewing and doing what we do from a change management perspective. Data governance. So where we talk about data accuracy, we obviously have to have data governance, make sure the data is always of good quality. Model transparency and traceability. Now, this is important because we want to make sure that at any given point in the cycle, we know exactly which data is coming from which source, how it's being treated by the model, where it's going from there, how it's being converted in the process, if at all, and so on. So that we can, if any point we realize that something needs to come out of the process, that we know where it is, how it came into the model, and we can take it out. Defining quality standards, so that's a no-brainer. We have to make sure that we define quality standards for this solution so that we don't implement it unless the model shows us those quality standards and it meets those standards for us. And lastly, model governance and framework, really, really important. Morgan Stanley is doing a lot of work in defining the process, controls, and governance around all of the work that we are doing in AI. And we want to make sure that we implement the same standards for whatever solutions we are working on as well. As we fine-tune the model, as we implement any refinements in the model, that we are following those same governance and review processes, et cetera, throughout the process. So those are some of the initial thoughts. And with that, I'm going to hand it over to my colleague, Samer here, who's going to talk about the path forward.
So where do we go from here? I think a lot of us know that AI is going to enhance efficiency and bring us gains. But really what we're looking at is that the gains that we achieve don't also come with a lack of reliability and other factors that actually wind up slowing us down. We also care about the fact that we have these cross-functional teams that are horizontal, such as change management teams. And when we look at them, we really consider the fact that they are handling many, many tickets across a slew of different things. And the context window of their mind is very different than the context windows that we're dealing with LLMs. So we're truly trying to figure out how do we scale these teams without letting go of a lot of the oversight that we've already put in place. So AI cannot wind up being a drop in efficiency and lower our standards. And then we also consider like how we train and adapt these models. And when we think about training these models and what we've been doing here, we're considering the fact that from an industry perspective, a lot of the rules and a lot of the oversight and governance cuts across all of us. So at some point, we need to think about how do we share these sets of rules so that the regulators, when they come in, can see that the LLMs are adhering to very rigorous rules and in the same fashion. It makes it easier for them, it makes it easier for us, and then we need to figure out like what is it that we do as a group to share our training sets, our prompts, how do we distribute that and make that more of an open source criteria that is similar to how we treat code today. And we're thinking through this, and I think this is the challenge that we have and we want to bring to everyone here, is just thinking how do we share this in the future? We are going to collectively make improvements to our strategy around generative AI, and we need to think about how that impacts our industry and how do we share that? It's not quite clear yet. And then lastly, when it comes to ethical AI, as we say, but in this interesting way, we're developing these systems, and they are going to be creating change tickets. A lot of our employees sign codes of conduct, and we know where they are, and we know how to hold them responsible. When we come to a system that's trying to get an approval, we all know that generative AI has been learning to game systems, so we need to ensure that it's actually accurate and it's doing the right thing, and the change tickets are filed properly with the data that we actually need. So we're looking through that as part of our controls and compliance and governance across that as well. With that, I will open it up for questions.
Yeah, we're still working on that, but it depends on how much data set you are doing. So that's why we first took a clustering approach. So on clustering, we find out that really how many clusters we have to do. And then it is always human in the loop, right? So once we get the clusters, someone needs to go through them manually and find out whether the clusters are correct or not. Or you have to do the other way. You can just find out, okay, this is my 6 categories, make on that. So we took both the approach. So, and it takes how long, when you're asking, you're talking about the training time or the human effort? Yeah, training time is pretty fast. I mean, if you're doing a normal CPU-based training, it's like a couple of hours you can do. And it depends on how much data you are working on. Do you mean the training and test set? Yeah. We always do the normal, traditional ML approach that we do. Take 80%, train on that, do 20%, and then test, and then again do the, just iterate through them. Yeah, the only thing I think the good part over here is, so LLM can generate text, right? Think about the quantitative part is one thing, qualitative part is another thing. GenAI is helping us to solve the qualitative part. It is actually reading a human input and trying to find out that whether, because see, what is right now happening, there are like, Rita and Rita's team are going through the 1,000 changes manually and trying to find out. And the to and fro between, it takes long, right? So what now, if this thing is in place, at least out of those 100 changes coming in, or I don't know the number, and Rita can just reject 90 of them and send back. These are not, I'm not going to look at them. I think that is the main key in this. Yeah. And now if this is integrated with the change control system, that's also good. I mean, you can see it over there that you are not filling up the actual stuff, right? Yeah. Sorry.
That was my question also.
That's a good question. Our thought is to, so as Jaya mentioned in her presentation, that today we do the quality check after the effect. But where we are going and where we want to go is, right at the time of ticket creation, there can be a feedback loop to the developer to say, okay, you put in a description, but it doesn't match my quality standard, right? So don't let them submit.
So it's like a self-service.
Exactly, yeah. Yes.
I had a technical question. What are you using Phi3 for? MPNet is for the clustering, I'm assuming.
Yeah.
And what is the Phi3?
Phi3 is for classification. Yeah, so we just trained it to do the classification. So just giving an example. So looking at the change request, it can say, okay, it is from the, say, trading department. So use the prompt, which is more specific for that department. Yeah, yeah.
And then after that, you're doing the clustering using MPNet.
No, clustering actually we just use during development time to find out how many types of change requests we have. That's like a development time effort.
It's not the inference.
Yeah,
so
not
from
yeah.
at the inference perspective, you're using Phi3
For the classification.
and MPNet for the vector embedding?
No, that MPNet we used for the clustering during development time.
Oh, got it.
Okay, so I just feed all them. I get the embeddings and then do a cluster analysis, a TSNE plot, and find out that how many actual groups we have. Yeah.
Sure, got it.
What kind of infrastructure did you need for all this? What did you use?
Infrastructure-wise, see, I mean, for the Phi3, you can run on CPU as well. You don't need a lot of things over there. And it is still in the POC stage. It is not like we are running it and we're just, it is in production or something.
And how many
Okay.
CPUs do you use?
Now, right now, things are pretty much in our development boxes and dev servers, yeah. And for Llama 3 to run the 8B, you need GPUs. You cannot run them in the CPUs. MPNet you can run on CPUs. You can run on your laptop as well.
Change based on that?
Do you think we really need this process? Because everything will be then. If it decides it's good, it will just go through.
So actually, we have done automation of request creation for the most part. And the only parts that's not automated is this qualitative stuff in the ticket. So all of the quantitative data, for example, what code version you're trying to promote, whether testing is completed or not, all of that comes from SDLC upfront. Is the qualitative stuff. For example, what's the change summary? So today we don't have a good way of gleaning the change summary. Again, maybe I'm sharing too much here, but you could actually glean it from the JIRAs, right? And that's where GenAI could play a big role, where some of this qualitative input in the ticket could come automatically going forward. Okay, so if I understood the question correctly, you're asking why we're doing the quality check after the effect, right? And that's basically just to benchmark the quality of tickets in the environment. Although as change managers, we are supposed to be looking at the quality of the ticket as well during the process, but doing this quality check after the effect helps us understand the deficiencies in our own process as well. For example, I have a team of people who are looking at these tickets and they're reviewing them and approving them or rejecting them. But are my people doing a good job of doing that, right? The quality check does make those deficiencies visible to us, where we can then we can reinforce the training and the processes for our own people as well. Absolutely. All right, any other questions? All right, great. Thank you everyone for joining and enjoy the rest of the conference.